SwayamPrabha. Digital India. Educated India.
Welcome to Groundwater Hydrology and Management NPTEL course. This is week 2, lecture 2. In this week, we are looking at the importance of groundwater, both at the international stage and also at the national stage. In the last class, we looked at the volumes of extraction per country. And also, we looked at globally where the groundwater resources are maximum. We looked at the major aquifers or major hydrologic groundwater units, and also some complex units where they are and what is the recharge rate. We will continue assessing why and how these groundwater volumes differ by country. This is very important to understand so that we get a sense of what management activities are needed for the groundwater management and conservation. So as we saw in the last class, we will pick up from the graph made by Professor Shah in 2014, looking at the groundwater extraction rates decadally, that is every 10 years. So we did notice that India has the most extracted volume with around 260 kilometer cube per year. And the second rank goes to US around 110. And China comes third with around 95 kilometer cube per year respectively. And we also saw a very important note that India extracts more, if not less, than the combination of the next two countries in line, which is combined groundwater use of US and China. We also notice that the Asian countries are ever increasing in groundwater use in China and all the major agricultural economies in Asia. Groundwater use is keeping on increasing with the most steepest increase noted in India. See this curve, it's exponential. Whereas others are almost linearly growing, but every year it is increasing. Whereas the Western countries are more or less stabilizing, US, Europe, etc. This clearly shows a shift from the groundwater use and or where they are using most of the water. It is very imperative to understand where the groundwater is mostly used. So now have an idea which countries are using it, and by a fair understanding of what the chief economy is driven by in each of these countries, we can assess where the groundwater is being used. Let's have a deeper look at it. So the major use, as we saw, is in the Asian countries. And those Asian countries are also noted as the chief food exporters in the world. They grow a lot of agriculture and they export it to these countries, especially where the groundwater use is almost stabilizing, Europe and US, for example. Let's take some data. So of the world irrigated area, which is around 300,000 hectares. So you can see the units here. You do have almost of the area irrigated with groundwater is around 37 to 40%. So of the total agriculturally irrigated land, it could be by surface irrigation, it could be by tube well, buying water, etc., dam water. Almost 37.5% is from your groundwater reserve. which is a big number. Okay. So moving on, let's see how the major continents are using water for irrigation. So Africa uses around 18.5% of groundwater, total area irrigated, only 18.5% is under groundwater irrigation. When you compare it to the world, it's very small, 2.3%. Okay, so if you remember, I did show you that big aquifers with big recharge and good volume are available in Africa. However, it's economically very expensive to take the water out. Therefore, they don't use much of groundwater. They are limited with energy resources, pumping, mechanical resources to actually access this water. So it is called economically stress situation. Then we go to the Americas, which is North and South America. You would see above the world average of 37.5, we have 44% of the total irrigated area under groundwater irrigation. This shows that most of these regions where irrigation is happening, they are almost 50%, nearing 50%, is tapped from groundwater. If you look at what they grow in these countries, it is mostly nuts, horticulture, which is fruits, orchards, etc., and a lot of exports. A lot of water is also used for grass to feed the meat market, livestock and other things, and then they export the meat. So a lot of their water is used for that. When you compare to the world, it's almost 20% of the groundwater irrigated area. Let's move on to Asia, where, as I said, most of the agriculture is happening. So now we're going to understand that groundwater is a big user in the world in Asian countries. So, and that is why you see a lot of volume being extracted. Okay. So if you look at the area under irrigation, irrigation is the application of water for crops. So it is not rain-fed, it is the Rabi season that we call in India. So it's the non-monsoon season or season where you apply water. And as I said, most of the water is applied by surface water, groundwater, or a combination of both. So in Asia, almost 38 to 40%, which is almost near the world average, is taken from groundwater. Okay, so almost the average sinks in. Where it is a bigger chunk is when you look at the area. So of the total area irrigated in the world with groundwater, 70% happens in Asia. And that is why you see India's groundwater extraction high, China, Bangladesh, Sri Lanka, all these Asian countries pumping a lot of groundwater. So even though the percentage of total area is small, because these are agrarian nations, which means a lot of agricultural activity is happening. And because of that, most of the water is supplied by surface water structures, whereas the Rabi season and the non-monsoon season is supplied by groundwater. So 38% of the total. However, of the groundwater use area in the world, 70 to 71% is from Asia. So Asian regions are combinedly the most extracting regions for groundwater in the world. Then when you go to Europe, the irrigation is very small. Look at the area size. It's almost that of Africa's, which means not much irrigation happens. Very less agriculture productivity, and of that, even lesser is for groundwater irrigation. So only 32.4%, much lower than the world average. And of the world area, only 6 to 7% is under groundwater irrigation in Europe. So the pumps and all the technologies they use may not be applicable for Asian countries. So please understand this. Yes, there are a lot of technologies available in Europe and Western countries, but the system here is totally different. The volumes we extract are totally different, much higher. So we need better engineering and natural solutions to manage groundwater. Then you come to Oceania, where it's very negligible. So if you just look at the major continents, as I said, Asia has been the chief producer of agricultural products. and especially your more water intensive crops like sugarcane, rice, vegetables, fruits, etc. And they are exported. Okay, so you export these products out for a very low amount of money. So this data clearly shows where the food is mostly produced and how it is also shifted to these other countries for a very less price. And so you are exporting your groundwater for a very, very less price. So most importantly, without the price concept, if you look at it, it is very important to understand that most of the groundwater irrigation happens in Asia. And also on top of that, so above and beyond that, around 62% of the irrigation is by surface water. So please do not disconnect surface water and groundwater, because surface water leads to groundwater. So that we'll discuss in the physical hydrology section. So moving on, we'll take a look at the groundwater socio-ecologies in agriculture, which means now we know that where the irrigation is happening, where how much groundwater resources are being used. Let's see what they use it for. I was giving examples like rice, sugarcane, based on my reading and experiences working with these countries. But it is also important to see what data shows. So the yellow region is the arid agrarian system, which is very less water. And based on that, there are some agrarian systems. Example, some vegetables, fruits, dates, palm, all those things. So you see, Middle Eastern countries are occupying that. Then the groundwater where it is used for industrial agriculture. So industrial agriculture includes mass farming, like acres and acres of land managed by one well or a big massive well. And then also industrial agriculture includes livestock rearing at an industrial scale. So there's a lot of these countries. So if you look at that, Europe and your US and Australia come under the industrial agricultural category, and they are mostly the well-developed countries. So they are very developed nations, and they use the water very wisely, thereby conserving water and using it for more industrial and profit. So industrial activities and profit. Okay, so you can see South Africa comes under that, and all these European nations and Australia, US come under that. Then we go to the small landholder intensive agriculture. So this is where the chunk of Australia comes. Asia comes. If you look at most of Asian countries are agrarian in nature, are dependent on agriculture, and they are small land holding size. China's data is not available to compare that very clearly. However, if you look at India, you have the average land holding size approximately at 1 hectare. So these are very small land holding units and a lot of agriculture activity, intensive agriculture. So here is where groundwater is being extracted at unsustainable rates across Asian countries. Okay. So, and also the northern part of Africa and Mexico. So these are the places where groundwater management is needed. And or there is no collective use. There's no options for collective use because they are isolated as small landholders, and there are more and more management needed. Then we get into the extensive agro-pastoralism. So this is the face, or this is the vertical where you see more agriculture is for rearing livestock and those kind of activities. As I said, meat industry, and then poultry industry, chicken feed, all those things. So there is agriculture happening, and there is groundwater use for that agriculture, but the product is not mostly for human consumption, but for livestock, cattle, other types of meat industries like chicken and other things, where it is converted to one farm to the other. And that meat is being exported to countries as a product. So you always see meat coming from Brazil and other things. So here's where extensive agro-pastoralism happens, and the groundwater use is that. So roughly you get an idea where most of the groundwater activities are, which are the red zones. and it is intensive agriculture for food. So rice, sugarcane, crops, etc. Whereas your agro-pastoralism is for grass, for example, which may not consume as much as water as sugarcane and rice. So, and then we get into the industrial phase. So we do have now a good spread of countries. And fortunately or unfortunately, if you draw a line between the red and the orange countries, you see that the red countries are mostly the underdeveloped, developing poor nations like Nepal is there, for lower economies. Pakistan, Afghanistan, Iran, all those countries are there, and India is there as a developing nation, along with China as a developed nation. So all these nations are cornered in the small intensive agriculture for groundwater, whereas the developed nations, including Australia, US and European countries, use it for excuse me, industrial agriculture. So there's a big difference in what we see. Moving on, we can also see countries where groundwater use is not significant, including Russia, Canada, and all those cold countries, Finland, etc. So here groundwater use is negligible for agriculture, and that is very clearly understood with what they do. So groundwater in Canada is very less, maybe for industrial it is, not for industrial agriculture. So where does the food come from these countries? It comes from most of the Asian countries. So here's where most of the virtual water fruit print and also the water export happens. So now we have a good idea of which are the countries that are using more groundwater and what are they using it for. They're using it for agriculture, and are they using it for high cost agriculture or industrial very smart agriculture? These things have been discussed in these chapters. So the quick question is, if we continue like this, then the developed nations will always be developed and rich, whereas the poor nations will be using more water for a very low profit, and they will never make good profit and or become developed nations in terms of agriculture. It's very difficult because the groundwater resource is coming down. So that is what the core of this course is. We are aiming to manage groundwater properly so that it is more sustainably used in the future. So given that groundwater has become a very, very important aspect in the Asian countries, it's important to see the structure of groundwater economies. And so here's where you see the annual groundwater use by different data. So 2014 shows data from different resources. You see China using 105 kilometer cube per year annual groundwater extraction or use. The good part of this table is it shows you how many wells are they using for extracting that much of volume of water, okay? And abstraction per well. So if you have one well, how much water on average do they extract? And what is the proportion of population using the groundwater? So if you look at China, 4.5 million wells are there. There will be more now. And the abstraction is 23,000 cubic meters per year per well. Okay. So what does this tell you is the number of wells spread across the country, and also what are the techniques, technologies that they use, and the size of the land that they irrigate from one well. So look at 23,000 cubic meters per year. That's a good fair amount of land that can be irrigated. We jump down to India, where India is a major user of groundwater, 230 kilometer cube per year. These numbers would differ, varying on the reports that you see or the studies you see. So for the actual values, I recommend you to look at the Central Groundwater Board data, where it parks it around 265 to 60 kilometer cube per year. So here in India, the second row, you see 20 million wells, more than 5 times the wells in China. Look at the size of China, look at the size of India, and 11,500 cubic meter per year per well. So that also gives you an idea of what is the land size that is used for one well. So is it economical? Look at the energy that they put in a well. how much extraction goes, how much wastage goes, all these things. So it is clear that most of the population is consuming groundwater, look at 55 to 60%. And most importantly, they individually use it. It's not like collective use. 20 million wells compared to 4.5 million wells in China, and the amount of water that is extracted per well clearly shows that it's more localized use of groundwater rather than sharing or mass farming, mass use of groundwater. So this causes multiple wells to be installed. Just think about it. You have a land and your neighbor has a land. Instead of having one well for both the lands just adjacent to each other, two lands are together. Instead of having one well in between for both, you will have one farmer having one well, the other farmer having another well. So this is how wells multiply in India. And the cost is expensive because to drill a well, one well is almost the same depending on the location. So instead of drilling one well with a particular depth, now you're drilling two wells, and that is expensive. The water is also being used very inefficiently. Energy is lost in pumping, those kind of things. Let's compare it to other lower user countries like Iran, Mexico, and Pakistan. You have almost 0.5 million wells and 0.09 million wells in Mexico. And if you look at Mexico's groundwater extraction per well, it's humongous, 414,000 meter cube per year, which means they have bigger wells and bigger extraction wells, and that is used for industrial scale because you take it and or give it to consumption units like cities, domestic use units. So it is good to understand from this table that countries use groundwater, but most importantly, are they isolating it by different partners? And are there too many wells, those kind of things, energy loss, what is the population using it? Come to Pakistan's part of Punjab, and you could see around 45 cubic meters, kilometer cube of water is used with 0.5 million wells. 90,000 meter cube per year, which is much higher than India in terms of per well abstraction, and 60 to 65. So more percentage of people are dependent on this groundwater. So a lot of water is being extracted by very less amount of wells. Okay. So this also looks at maybe sharing of groundwater or a central agency which is pumping the water and distributing to other regions. Okay, come down to US, which is 198 kilometer cube per year according to this report, but the number of wells they have is very small. If you know, most of the groundwater wells in US have to be permitted by the government. You have to declare. And they monitor it. Every well is almost monitored. So you do have good data, and those are massive wells. If you look at the pumps, those are industrial pumps which pump a lot of volume of water and cater to large pieces of land, not 1 hectare. So it's big lands and mass farming happens. So you don't need that many wells, and you have an industrial agricultural system as we saw in this image. So mostly it is used for industrial agriculture, and the population which is dependent or using it is only less than 2%. So this gives a clear idea. This image gives a clear idea of how the water is used, where the water is used, and the number of wells spread across the countries, and per well abstraction. It gives you a very short experience on if the well is shared or used individually, and other countries how they use it compared to India. So what are the specific crops? It's a very important slide which is done by in a study by Dallin et al. In 2017, mapping the major groundwater uses in the world. So all these countries that you see, groundwater countries, not all the countries are mapped here, only some countries are. And the size of your pie chart gives you the size of the groundwater extracted. So if it is circle, it is above 30 kilometer cube per year. So you know that India, Pakistan, China, US are all above 30 kilometer cube, so they have a bigger circle. And also they map the key crops that they grow. So I've been telling you where the water is used, how many wells they use, and how many wells uh, per million are used in the country, and per well extraction rate. Now let's see what crops they grow, most of the crops using groundwater. So you see that the chief or the key highly ranked India in groundwater use, you see more wheat and rice being used by groundwater irrigation. So wheat and rice are used more, followed by sugarcane. All these are highly water intensive crops. And then you have cotton, another good water intensive crop, followed by other, which is very diverse. It depends on where you are in India. It could be millets, it could be turmeric, chilies, horticulture, anything you could name it, because it's very diverse. Okay. So you have a lot of other agencies here. But when you go to your China, you see that more of the groundwater used for rice. And because they're a rice eating nation when compared to wheat, India has almost half and half rice and half wheat. So China has a lot of rice plus maize. So maize is used a lot, and groundwater is being shared for all these. Cotton very less. Come to comparatively less. If you come to US, which is the next ranked groundwater extractor, you could see a total change. Now more pink color is there for fodder. Fodder is the grass that the cows and livestock eat. As I said, they are industrial groundwater users. They use it for meat industry rather than crops and then rice and those kind of things. So rice is very less. So after fodder, it goes to other, which is including horticulture, nuts like almonds and stuff that you get from US, even in Indian market. And then you have maize. So maize, corn, they use a lot for sugar and also ethanol. Then you have Australia is very less compared to other parts of the world. Mexico has a lot of other crops. So it gives you a very clear understanding of where the groundwater is used, what are the key crops that they grew to sustain this groundwater use and activity, and are they diversifying their crops? So if you look at China and India, there's not much diversification. More rice means more groundwater use, same as wheat. So wheat and rice also are having equal proportions in India when it comes to consumption. So North India has a lot of wheat, whereas South they have a lot of rice. Okay, so these are typical crops that are grown using groundwater. And now we have an idea of can you do something? Can you do something for changing this behavior? If you take a step back and answer this question, is it that easy to change a dietary preference by these nations? Let's take China. Can you change their rice eating habits? It's really going to be very difficult. Same as India. So if you go to India South, you cannot quickly change them to another diet, and or the North from wheat to something else, a less water intensive crops, for example, maize or millets. So this is where the groundwater demand and supply scenarios have to be discussed. And this study clearly shows you where these major economies are in using groundwater, and how much do they use in terms of groundwater volume. Is it by range above the 30 kilometer cube to less than 1 kilometer cube? And what are the key specific crops that they grow? The other question to answer in these key countries in extracting groundwater is, do they need that much? Do they need that much productivity? Because at the most of the time you start exporting, but is the export water also added into it? Okay, so you're exporting rice from India to the Western countries, or from China to Western countries. How much are you calculating the groundwater is the question, because it is an unseeable quantity. You cannot put a value for groundwater. And that is the problem for groundwater management. Whereas the other countries, the Western and Europe countries, they have clearly understood the value of groundwater and using it for a high profit. So 1 kilogram of meat is much more expensive than 1 kilogram of rice. If you look at the comparisons, same goes to maize and other things that they grow. So it has to be used to communicate some important decisions to the policymakers and farmers in India. How do you conserve groundwater and what can be done to change the attitude of groundwater use in India? We'll see more of this in the next lecture, because such use of groundwater is very unsustainable. I've been using this for a long time, but what water are you using is a question. Are you using the annual rechargeable water? Not exactly. Are you using water from 10 years, 100 years ago? Yes. That is what we will discuss in the principles of groundwater and occurrences of groundwater, etc. Okay. So if this habit goes on, where you use groundwater for mostly highly water intensive crops, it is very unsustainable, and more likely the groundwater system is going to be under tremendous stress, and the agriculture system may collapse. So it is very important to understand groundwater use in these countries. With this, I just will introduce the water stress and water map, which we'll be discussing more in detail in the next class. Just if you look at the previous image and where the major groundwater use and what grow, and the study by WRI on the stress indicators and countries where water stress and groundwater are going to be, it almost matches. For example, India, the highest groundwater extractor, is also showing a high water stress index compared to China and other countries. Similarly, wherever the groundwater is extracted, you're going to see a lot of water stress. Even in the US, in some regions where groundwater is highly extracted, is going to be under tremendous stress. So we'll discuss this in detail in the next class.